Light doesn't travel, not the way you think it does. And I can prove it with your windshield. You're driving at night. Rain falls straight down from the sky, but watch your windshield. The drops don't hit straight. They slant toward you, streaking at an angle across the glass. The rain hasn't changed direction. You have. Your motion bends where the rain appears to come from. Light does exactly this. Now hold that image, because what I'm about to show you is what happens when you replace raindrops with starlight and replace your car with something moving at the speed of light. 299,792,458 meters per second. You've been told what light speed travel looks like. Stars streaking past you in long white lines. The universe smearing into a blur of motion. Science fiction burned this image into your mind. But that image is wrong. Completely, fundamentally wrong. What you would actually see at light speed is so disturbing, so alien to human experience, that when physicists first calculated it, they checked their math 3 times, hoping for a mistake. There was no mistake. By the end of this, you won't just understand what you'd see. You'll understand why seeing itself breaks apart at that speed. Why the very act of looking becomes impossible at the one speed the universe seems to care about most. The answer waiting at the end goes somewhere most explanations are afraid to go. So let me ask the question properly. Not what would it look like? That's too casual. The real question is, what would you actually see if you moved at the speed of light? What would enter your eyes? What would your brain receive? To answer this, we need to start with something you've already experienced, something so ordinary you've never questioned it. When you see anything, your hand, a tree, the moon, you're not seeing the object itself. You're seeing light that left that object and traveled into your eyes. This is easy to forget. Seeing feels direct, immediate, like reality is just there in front of you. But it isn't. Seeing is receiving. You stand still. Light comes to you, always, without exception. You don't reach out and grab an image of the world. The world sends light toward you, and your eyes catch whatever arrives. Now, what changes when you start moving toward the light? Go back to that rain. Standing still on the street, raindrops fall straight down onto your head. Start walking, and the rain seems to slant toward your face. Walk faster, the slant increases. Run, and rain that was falling behind you now hits the back of your head at an angle, drifting forward. Your motion changes the angle at which rain reaches you. Light does the same thing. When you move toward light sources, the light doesn't arrive from where you expect. It shifts. It bends toward your direction of motion. Astronomers discovered this over 3 centuries ago, and they call it aberration, the bending where light appears to come from. Simply because you are moving. Put simply, your motion changes where you see things, not where they actually are. You don't see the universe. You see your collision with it. This means something profound. If you're moving, you don't see stars where they truly are. You see them shifted in the direction you're traveling. The faster you move, the bigger the shift. At everyday speeds, cars, planes, even spacecraft, the shift is tiny, unnoticeable, irrelevant, but we're not talking about everyday speeds. Stand outside on a clear night. Stars surround you, ahead, behind, left, right, above. They seem fixed in place, permanent points of light scattered evenly across the entire sky. You turn your head, and different stars come into view. The universe feels balanced, symmetrical, everywhere. Now accelerate, not to car speed, not to rocket speed. Accelerate to half the speed of light. Watch what happens to those stars. They move, not because the stars themselves are moving, but because your speed changes where their light appears to come from. Stars behind you begin drifting forward in your field of view. Stars to your side slide toward the front. It's like that rain again, but now the rain is starlight. And you're moving so fast that all of it starts slanting toward your face. Or rather, it's not that stars move. It's that the angle at which their light reaches your eyes shifts dramatically. You see them in different positions than someone standing still would see them. The faster you go, the more the entire sky crowds toward the direction you're heading. Let me give you a number to hold on to. At 90% of light speed, a star that was directly beside you, 90 degrees to your left, perfectly perpendicular to your motion, now appears only 25 degrees from straight ahead. A star that was almost behind you now appears in front of you. The entire universe starts piling up into the forward direction, but we haven't reached light speed yet. We're at 90%. There's still 10 to go, and in that final 10%, something terrifying begins. The sky ahead becomes blindingly bright. Stars aren't just shifting forward, they're crushing together, overlapping, piling into a smaller and smaller circle directly in front of you. Meanwhile, behind you, the darkness grows, not because stars are disappearing, but because their light can no longer catch you. You're outrunning the view. At 99% of light speed, almost the entire universe is crammed into a tiny disk ahead of you. Behind you stretches absolute blackness, pure nothing, because no light from that direction can reach your eyes anymore. And you're still not at light speed. So far, you've watched stars slide across the sky. You've seen the universe crowd forward, piling into an ever-shrinking circle ahead of you. You've watched darkness swallow everything behind, but I've only shown you where things appear. I haven't shown you what they look like when they get there. Because at these speeds, light doesn't just shift position. Light itself changes. You've heard this before, even if you don't remember where. An ambulance approaches, siren wailing. The pitch sounds higher. The ambulance passes, moves away, and the pitch drops lower. This is the Doppler effect. When something moves toward you, the waves it sends get compressed. When it moves away, the waves stretch out. Sound waves do this. And so does light. Light is a wave. It has a frequency, just like sound. And that frequency is what your eyes interpret as color. High frequency, short waves, you see blue. Low frequency, long waves, you see red. The rainbow between is just different frequencies landing on your retina. Now, move toward a star at half-light speed. What happens? The light from that star gets compressed. Its frequency increases. A yellow star shifts toward blue. A red star shifts toward yellow. Everything ahead of you slides up the spectrum toward higher frequencies, bluer colors. At the same time, anything behind you, if light could still reach you from there, gets stretched. Blue stars become red. Red stars become infrared. Colors slide down the spectrum toward lower frequencies. This much you might have heard before. But here's what no one tells you about what happens at extreme speeds. At 90% of light speed, the stars ahead of you haven't just shifted to blue, they've shifted past blue, past violet. The light has compressed into ultraviolet, frequencies your eyes cannot detect. The stars are still there, the light is still arriving. But you cannot see it. Your biology has no receptor for those wavelengths. Curious, very curious. Push faster, 95%. The ultraviolet compresses further into X-rays. Faster still, and you reach gamma rays, the same radiation produced by nuclear explosions. The stars ahead of you are now blasting you with gamma radiation. They look like nothing because your eyes see nothing in that range. Meanwhile, the few photons still reaching you from behind have stretched into infrared, then microwaves, then radio waves, also invisible. What this really means is, at near light speed, visible light stops being visible. Let me be more precise. You wouldn't see darkness because there's no light. You'd see darkness because the light has been squeezed or stretched beyond what human eyes evolved to detect. The universe is still sending you information. You just can't receive it anymore. The fastest you can go is the speed at which you become blind. If this feels impossible to picture, good. Your brain was built for walking speeds, not cosmic ones. Your intuition evolved on a planet where the fastest thing you'd ever encounter was a thrown rock or a running predator. Nothing in your ancestry prepared you for this. The confusion you feel isn't failure. It's honesty. Now let me take you somewhere that makes this even stranger. In 1727, an astronomer named Bradley was trying to measure something unrelated, how far away certain stars were. He kept noticing an error in his observations. Stars seemed to shift position slightly over the course of a year. But first he assumed his instruments were flawed. He rebuilt them. The shift persisted. Then he realized his instruments were fine. The stars weren't moving. Earth was. As Earth orbits the sun, it changes direction, and that changing motion altered the angle at which starlight entered his telescope. He had discovered aberration by accident. Proof that what you see depends on how you're moving. 3 centuries ago, without any theory to guide him, Bradley had stumbled onto the first clue that seeing is not passive. Seeing is shaped by your motion through the universe. You're beginning to see it now, aren't you? What you observe isn't simply what's out there. It's what's out there filtered through how fast you're moving in what direction, relative to what's sending you light. Seeing is not a window. Seeing is a collision, and every collision depends on both parties, the thing sending light and the thing receiving it. So far, I've described what happens at 90%, at 95%, at 99% of light speed. Extreme, yes. Bizarre, yes. But still less than light speed. Still approaching, not arriving. Now we go to the edge, to light speed itself. And here is where everything you think you understand about seeing, about light, about time, all of it shatters, not bends, not stretches, shatters completely in ways I cannot soften or make comfortable. Because at light speed, it's not just that the universe looks different. At light speed, time itself stops, and without time, the very concept of seeing loses all meaning. Time. I've been avoiding this word. I've shown you stars sliding across the sky, colors shifting beyond vision, the universe crushing into a single point ahead of you. All of that was about space, where things appear, what wavelengths reach your eyes. That space and time are not separate. They never were. They are traded, one for the other, in an exchange so fundamental that ignoring it would be lying to you. So let me stop avoiding it. You experience time right now. One moment, then another. A second passes, then the next. This feels like the most solid thing in existence, more reliable than your own heartbeat, more constant than anything you can touch. Time moves forward, always, for everyone, at the same rate. That feeling is wrong, not slightly wrong, not needs adjustment, wrong, fundamentally, structurally wrong, in a way that has been measured with atomic clocks, accurate to 1 second in 300 million years. Here's what's actually happening. You are always moving through both space and time. Right now, sitting still, you're moving through time at maximum speed. 1 second per second, the fastest anything can move through time. But start moving through space, and something strange happens. Your movement through time slows down. Not poetically, not metaphorically. Actually, let me give you something concrete. In the 1970s, scientists put atomic clocks on airplanes and flew them around the world. When the planes landed, the clocks were compared to identical clocks that stayed on the ground. The flying clocks had fallen behind. Not because they were broken, not because of vibration or air pressure. They had experienced less time. The difference was tiny, billionths of a second, but it was there. Measurable, undeniable. At airplane speed, the effect is almost nothing. At rocket speed, it's still small, but at 90% of light speed, time for you passes at less than half the rate of someone standing still. At 99%, time nearly stops. Your heart beats once, and years pass for the rest of the universe. Strange, profoundly strange. And at light speed itself? No, wait. Let me be careful here. Stops isn't the right word, because stops implies time exists, but freezes, like a paused video. That's not what happens. At light speed, time doesn't slow and then halt. Time ceases to be a meaningful concept. There is no duration, no during, no before image, no after image, no sequence of moments that could be called experience. Think about watching a movie. At normal speed, scenes unfold. A beginning, a middle, an end. Characters move. Events happen. Now speed it up. Faster. The scenes blur together. Faster still. At some point, the entire movie becomes a single flash. Beginning and end collapse into one instant. There's no story anymore, because a story requires time, and you've compressed time to zero. That's what happens to light's experience of the universe. Consider a photon, a single particle of light, leaving a star in a distant galaxy. From your perspective, watching from Earth, that photon travels for millions of years before reaching your eye. It crosses unimaginable distances, passes through intergalactic voids, finally arrives at your retina after an epic journey through space and time. From the photon's perspective, if a photon could have perspective, none of that happened. The departure and the arrival are the same moment, not similar moments, not very close moments, the same moment. The photon does not experience the journey because there is no time in which to experience anything. The star's surface and your eye are, from light's frame of reference, the same place at the same instant. Let that settle. Remember that star 90 degrees beside you, the one that shifted to 25 degrees ahead at 90% of light speed? At actual light speed. That star, along with every other star, every galaxy, every photon of light from every direction in the entire universe compresses into a single point directly in front of you. One point. Every direction, now one direction. At light speed, you would see everything in the universe at once and see nothing at all. Everything and nothing. The same moment. Every photon from every star, every galaxy, every corner of existence, all of it crushed into one blinding point ahead of you. But here's what breaks the mind. Time isn't passing for you, and seeing requires time. Light has to enter your eye. Signals have to travel to your brain. Your brain has to process, interpret, construct an image. All of that takes time. Billionths of a second, but still time. Without time, none of that happens. You would contain all the visual information in the universe. You would experience none of it. If your mind is rebelling right now, so did mine when I first worked through these equations. So did every physicist who has followed this thread to its conclusion. We can write down the mathematics. We can verify the predictions with experiments. We can confirm that clocks slow, that time dilates, that everything I'm telling you is not speculation, but measurement. But the mathematics describe something no human can truly imagine. We evolved to survive on a small planet at slow speeds. Our intuitions are tools for finding food and avoiding predators, not for comprehending the dissolution of time at the universe's speed limit. Light doesn't experience the journey. Light doesn't experience time. From light's own frame, emission and absorption are not two events separated by distance and duration. They are one event, a photon born in the core of the sun and absorbed by your eye 8 minutes later. For that photon, those 2 moments are not separated by 8 minutes. They are not separated at all. The sun's core and your retina are, from light's own frame, the same place at the same moment. Light crosses the universe without experiencing a single moment of the journey. Actually, crosses isn't right either. Crosses implies distance traveled over time. Light doesn't experience either. It doesn't travel anywhere from its own perspective. It simply connects 2 points. Think of light as a bridge, not a bridge you walk across where you start at one end and finish at the other. A bridge where both ends touch the same point. You are the one who experiences distance when you look at the bridge. You are the one who experiences the time it takes for light to reach you. Light experiences neither. So if light sees everything and nothing, experiences no time, connects departure and arrival as one single event, then what does that mean for you? Right now, watching light from the outside, what exactly have you been looking at your entire life? And this is precisely where it becomes uncomfortable. Not strange, not interesting. Uncomfortable in the way that truths you cannot unfeel are uncomfortable, because everything you have ever seen, every face you have loved, every sunset that made you pause, every star that made you wonder, all of it came to you through something that does not experience time. Light is your only window to the universe. You have no other. You cannot see without it. Close your eyes, remove all light, and you see nothing. Every image, every color, every shape that has ever entered your awareness arrived on the back of a photon. That photon, that messenger, that carrier of everything visual, it operates outside of time entirely. Light carries information from events. It delivers images from distant places, but the messenger itself has no experience of the delivery, no journey, no waiting, no duration between leaving and arriving. You experience time. Light does not. And yet light is the only reason you see anything that happens in time. Consider that. Imagine receiving a letter from someone who has no concept of time, no past, no future, no sense of when. The letter describes events in sequence. This happened, then that happened. But the messenger who delivered it experienced no journey to the messenger. Your hand receiving the letter and the writer's hand releasing it are the same moment. The letter contains information about time. The messenger exists outside of it. That messenger is light. Every photon reaching your eyes is an instant telegram from elsewhere. Instant from light's own perspective, though you experience it as arriving from the past. Now, you're beginning to feel something shift, aren't you? Something about what seeing means. Return with me to where we started. Rain on a windshield, falling straight down but slanting toward you because of your motion. That slant reveals something simple. How you receive what's coming at you depends on how you're moving. Your motion shapes what arrives. At everyday speeds, the shaping is tiny, ignorable. At near light speed, the shaping becomes total. Every star, every photon, every piece of light from every direction, all of it piles into one point ahead of you, behind you, nothing. Complete darkness. Not because the universe disappeared, but because you're moving too fast for light from behind to reach you. The rain has all slanted forward. Every drop now hits your face. None touch your back. And at light speed itself, that single point ahead contains everything. All the light in the universe compressed into one place. But you cannot see it, because seeing requires time. And time has stopped for you. The ultimate view becomes the ultimate blindness. Think about what this means for right now, for this moment. Wherever you are not seeing the present. You have never seen the present. You have never seen anything in the present. The light entering your eyes left its source in the past. The face of someone standing 3 feet away, you see them as they were 10 nanoseconds ago. The sun, you see it as it was 8 minutes ago. The nearest star beyond the sun, you see it as it was 4 years ago. A distant galaxy, you see it as it was millions of years ago. You do not see what is. You see what was. Only what was. Always what was. Your entire visual experience is memory. Not metaphorically. Literally. The universe sends you postcards from the past, and those postcards travel on the backs of timeless messengers who experience no journey at all. In 1727, James Bradley discovered aberration by accident. He was trying to measure stellar distances and instead discovered that Earth's motion changes where stars appear to be. He couldn't have known where that insight led. He couldn't have known that the same thread followed far enough would reveal this at the speed of light. Seeing becomes impossible. The thing that allows you to see, light itself, does not experience the journey it makes to reach your eyes. The window through which you observe reality is made of something that exists outside of reality's flow. I can describe this with mathematics. I can point to experiments that confirm every prediction. Atomic clocks, particle accelerators, satellites that must correct for time dilation or GPS would fail within hours. The evidence is overwhelming, repeated, precise. But why the universe is structured this way? Why there is a speed limit at all? Why that limit is precisely 299,790,548 meters per second? Why reaching that limit dissolves time into meaninglessness? I cannot tell you. No one can. Not yet. We follow the evidence. The evidence led here. We can measure what happens with extraordinary precision. Why existence chose these rules remains an open question. Perhaps the deepest question. And I will not pretend otherwise. So, you asked what you would see at light speed. Now you would see everything, every photon, from every direction, the entire visible universe compressed into a single blazing point directly ahead of you. And you would see nothing, because seeing requires time, requires sequence, requires the slow biological process of light entering your eye and signals traveling to your brain and patterns being interpreted into images. At light speed, time stops. Sequence ends. The process cannot happen. Everything and nothing. The ultimate view and the ultimate blindness. The same moment. You started with a simple question, a child's question, really. What would it look like to travel at the speed of light? The question answered itself by dissolving. At light speed, looking loses meaning. The act of seeing requires the one thing light speed removes. This is not a limitation imposed from outside. This is not the universe punishing you for trying to go too fast. This is the structure of existence itself. Light shows you everything, and light itself experiences nothing. You live in time, and that is exactly why you can see at all. Light shows you the universe, but light itself experiences none of it. You live in time. Light does not. That is not limitation. That is the window.